group 17 elements. The P block is having group 17. The elements of group 17 are called in general halogens or fluorine family. They are called halogens. The reason is because halo means salt. They basically forms the salt. The group 17 includes fluorine, chlorine, bromine, iodine and astatine. This astatine is radioactive, so it's not studied in detail. So basically we concentrate our studies to these four elements. What you need to know about their first nature is that all these four from fluorine to iodine are regarded as non-metals, whereas astatine is the only one in the group which is called metalloid. Now let us move to their occurrence then. Now we know fluorine. Let's discuss occurrence of fluorine. Fluorine exists in the form of salts. Mainly its major salts are the fluorospar CaF2, or we can have its cornellite Na3, cryolite Na3 Al F6, it's cryolite, and it also exists in the form of fluorapatite, which is calcium phosphate CaF2. Along with this, small quantity of fluorine is also available in soil, in the teeth and the bones of the animals. Chlorine. Chlorine, the major source of chlorine is the seawater. 2.5% of the seawater is chlorine basically, and it is present there in the form of number of salts. The other major source of chlorine is your rock salt NaCl, and we can have cornellite like KCl, MgCl2, 6H2O. Now let's talk about bromide and iodide. They are also present in the seawater. Seawater is one of the major sources of bromine and iodine. They are present in their seabeds and sea plants. And the main source again of iodine is those sea plants, as well as they can also be obtained from the other salts. Like the chili saltpeter contains a small amount of the sodium iodide also. So these are how they occur in the nature, mainly in the form of salts. That is why they are called halogens. Now let us discuss their electronic configuration. Their general electronic configuration is ns2np5. So they all are having how many valence electrons? 7. That is why they are in 17th group. So all of these, this is 2s2 2p5, 3s2 3p5, 4s2 4p5, so like this. Now let us discuss their atomic size. Remember, they are smallest in their respective periods. In every period, halogens are having the smallest atomic size. It's not the noble gases, remember. We know across the period the atomic size decreases, but it decreases till only group number 17 because what happens is their covalent radius is compared with the van der Waals radius of the noble gases. That is why that becomes very, very large, and what we find is they are the smallest in their respective periods. And what we find is fluorine is exceptionally small and atomic size increases down the group, the reason being the new shells are added and the nuclear charge is not becoming effective anymore. So this was your atomic size of the group 17 elements. Now let us discuss their ionization energies. It's the second highest after noble gases in their respective periods. Remember, they are just after noble gases in their ionization energies because their sizes are very small and nuclear charge is very, very high. That's why it's like this. And so what we find is ionization enthalpy of fluorine is highest in group 17 and ionization energies decreases down the group because atomic size increases. So that's the basic system of this we have. Let us discuss their electron affinity or electron gain enthalpy. Remember, they are having highest electron affinity in their respective periods because of very small atomic size. And what we find is, therefore, their electron gain enthalpies are highly negative and their electron affinity decreases down the group because atomic size increases. This is what the general is. But we know this, that electron affinity of fluorine when compared with chlorine, chlorine is having the highest electron affinity. So the highest electron affinity in periodic table is with chlorine. It's not with fluorine. The reason is it's having bigger 3p orbitals in which there are lesser interelectronic repulsions, whereas in this case they have smaller 2p orbitals in which they have more interelectronic repulsions. That's why chlorine's electron affinity is more than that of fluorine. That's most important to note. Then let us discuss their electronegativity. Electronegativity, again, it is highest in their respective periods and it decreases down the group. So fluorine is most electronegative, followed by chlorine, bromine and iodine. So this is what is the trend is. The reason is very obvious because the size increases, the ionization enthalpy decreases, electron affinity decreases, so the electronegativity also decreases down the group. So it's like this.